If black holes really behaved the way movies show, Earth wouldn't exist. No dramatic music. No cosmic vacuum cleaners. Just a quiet truth that most explanations miss. When people hear black hole, they imagine destruction. Stars being ripped apart, galaxies collapsing, space tearing itself open. But that picture is wrong. Not slightly wrong. Fundamentally wrong. And once you understand why, black holes become far more interesting than they are frightening. Welcome to the Missing Context. In this video, we're going to talk about black holes calmly, clearly, and honestly. No exaggeration, no fake mystery, no science fiction. By the end, you'll understand what black holes really are, why they don't behave the way people think, and why they're one of the most important ideas in modern science. Let's start simple. A black hole is not a monster, and it's not a hole in the usual sense. A black hole is a region of space where gravity becomes extremely strong. That's it. Nothing supernatural happens. No new force appears. Gravity becomes extreme because a large amount of mass is compressed into a very small space. The same rule that gives Earth gravity, the same rule that keeps planets orbiting stars, is responsible for black holes too, just pushed to its limit. Think about it this way. Earth has gravity. The Sun has stronger gravity because it has more mass. Now imagine a massive star collapsing inward. As it gets smaller, gravity gets stronger. Smaller still, stronger again. Eventually, gravity reaches a point where even light cannot escape. That's when a black hole forms. Not because physics breaks, but because it follows its rules perfectly. This brings us to an important idea: the event horizon. Despite how it's often described, the event horizon is not a surface. It's not a shell. It's not a wall. It's a boundary. Once something crosses it, returning becomes impossible. Not because gravity suddenly pulls harder, but because space itself is curved so extremely that out stops being a direction. Like walking north on Earth until north no longer exists. This detail changes everything. Now let's clear up the biggest misconception of all. Black holes do not suck things in. They don't pull objects from far away. They don't hunt planets. They don't chase stars. In fact, if the Sun were instantly replaced by a black hole of the same mass, Earth would continue orbiting exactly as it does now. Same distance, same speed, same orbit. Gravity depends on mass, not on whether something is glowing or invisible. So why does anything fall into a black hole at all? For the same reason things fall into stars or planets. They get too close and they don't have enough sideways motion to stay in orbit. That's it. Black holes aren't aggressive. They're patient. Another surprising truth. Most black holes are almost impossible to notice. They don't shine. They don't glow. They don't announce themselves. We usually find them indirectly, by watching stars or gas move around something we can't see. And there are many of them. Our galaxy alone likely contains millions of black holes. Most formed billions of years ago when massive stars collapsed. They've been quietly orbiting ever since. No chaos, no destruction. Just gravity doing what gravity always does. What happens inside a black hole? This is where certainty ends. According to our equations, the center contains something called a singularity, a point where density becomes incredibly high. But when physicists talk about infinities, it usually means our math has stopped working. Not that we fully understand reality. So when it comes to the inside of a black hole, we're looking at the edge of human knowledge. And good science admits that. You may have heard that falling into a black hole would stretch you like spaghetti. That can happen, but only for smaller black holes. For supermassive black holes, the ones at the centers of galaxies, you could cross the event horizon without noticing anything unusual at that exact moment. No sudden force. No dramatic pull. Just a quiet crossing. One you can never undo. That's far more unsettling than anything Hollywood shows. There's another deep question black holes raise. If something falls in, is its information lost forever? Physicists have debated this for decades, a problem known as the black hole information paradox. Right now, the best evidence suggests information is preserved somehow. But how? We don't yet know, and anyone who claims they do is oversimplifying. One last thing. Black holes pose no danger to Earth. The nearest known one is thousands of light years away, and the supermassive black hole at our galaxy's center has no noticeable effect on us at all. Black holes grow slowly over cosmic timescales. The universe is not waiting to swallow us. That fear comes from misunderstanding, not physics. Here's the missing context. Black holes are not symbols of chaos. They are symbols of order taken to its extreme. They are solutions to equations, predictions confirmed by observation, and tools that help us test the deepest laws of reality. They don't represent the universe breaking. They represent it working perfectly, even when pushed to its limits. If this explanation helped you see black holes differently, that's exactly what the missing context exists for. If you value calm, honest science without hype, fear, or exaggeration, consider subscribing. Not for trends, for understanding. Black holes aren't what you think. They're quieter, more subtle, and far more interesting than the myths around them. Thanks for watching.